CIET NCERT presents AudioBook Curiosity, Textbook of Science for Grade 8.
Page 80. Chapter 6. Pressure, Winds, Storms and Cyclones. A QR code is given on the page to access various elements and contents related to the chapter. On the background, we see a picture of a coastal area which is affected by a strong wind and storm. Thunder and lightning is also experienced by the people who are worried. Some children and some adults are rushing for shelter in the picture. Probe and ponder. Why are winds stronger on some days than on others? Why are water tanks usually placed at a height? Can air pressure really crush us? What causes storms and cyclones? If the earth stopped rotating, would cyclones still form? Share your questions. Some blank space is provided for you. On the bottom right of the page, we have a picture of 3 students who are filled with amazing curiosity with a big question mark in their mind. Page 81. You must have observed fallen leaves on the ground swirling in the air or being swept away, and trees swaying or even bending when a strong wind blows. Have you ever wondered why fallen leaves rise in the air or trees sway or bend? Does the wind exert force on fallen leaves to make them rise or on trees to bend? Record other similar effects of the force exerted by wind, like slamming of doors or rattling of windows or fluttering of clothes. How does the force exerted by wind make this happen? The force exerted by wind creates wind pressure, which causes these effects. In this chapter, we will explore the relationship between force and pressure and understand how they shape powerful natural events like thunderstorms and cyclones. 6.1. Pressure. Megha and her brother Pavan are going on a picnic. They walk to the picnic spot, carrying identical items in their bags. Figure 6.1. On the way, Pavan keeps adjusting his bag and looks uncomfortable. Megha asks, "Is there a problem with your bag?" Pavan responds, "Yes, it is hurting my shoulders." Megha says, "Both our bags are equally heavy. Why does your bag hurt and mine doesn't?" Pavan reflects for a minute and says, "Perhaps it is because of the difference in the straps of our bags. My bag has narrow straps while your bag has broad straps." Can the shape or size of the straps really make a difference? Let us try to find out. On the right of the page, we have figure 6.1 depicting Megha and Pavan carrying their bags. When we carry a bag, we feel its weight because of the force of gravity acting on our shoulders. The weight of the bag with narrow straps acts on a smaller area of our shoulders, whereas the weight of the bag with broad straps is spread out over a larger area of our shoulders. It is due to this reason that we feel more comfortable carrying a bag with broader straps than one with narrow straps, although both bags have the same weight. Since the area over which the force acts is involved, we define a quantity called pressure, which is the force per unit area. So, pressure is equal to force divided by area. At this stage, we will consider only those forces which act perpendicular to the surface on which the pressure is to be computed. Page 82. Broad straps reduce the pressure exerted by the bag on our shoulders as compared to narrow straps. Therefore, we feel more comfortable carrying a bag with broad straps. Can you now understand why it feels easier to lift a water-filled bucket with a broad handle than with a narrow handle? Refer to figure 6.2. Figure 6.2 on the top left of the page depicts two different buckets with broad and narrow handles. Similarly, we have seen that when people carry loads like pots or vegetable baskets on their heads, they often place a round piece of cloth under the loads. Refer to figure 6.3. In both cases, the objective is to reduce pressure by increasing the area over which the weight acts. On the left of the page, figure 6.3 depicts two persons carrying loads on their heads. Pressure is defined as the force per unit area. The SI unit of force is Newton and that of area is square meter. Therefore, the SI unit of pressure is Newton per square meter, denoted by capital N/m². This unit is also called a Pascal, denoted by capital PA. If a force of 100 newtons is applied on a cardboard of area 2 square meters, then the pressure applied on the cardboard will be pressure is equal to force upon area is equal to 100 newtons divided by 2 square meters, which is equal to 15 newtons per square meter. There are many situations in daily life where pressure plays a role. Conduct the activities given in Table 6.1 and record your observations. Explain how pressure influences the mode of action undertaken for each activity. Safety first. The activities listed in Table 6.1 should be conducted under the supervision of an adult. Table 6.1. Record your observations. Activity: driving an iron nail. Modes of action: by the head of the nail, which is depicted in the picture, by the pointed end of the nail, which is depicted in the picture. Easy or difficult to perform. Give reasons. Blank space is given for you. Activity: cutting an apple with a knife. Modes of action: using the sharp edge of the knife, depicted in the picture, using the blunt edge of the knife, depicted in the picture. Easy or difficult to perform? Give reasons. Blank space has been provided. Page 83. What can you conclude from your observations in Table 6.1? We conclude that when the area over which a force applied is smaller, the resulting pressure is higher, making it easier to do certain tasks. This is why it is easier to drive a nail using its pointed end, and it is easier to cut an apple with the sharp edge of a knife. You must have noted overhead water tanks. Refer to figure 6.4 in your locality or on the rooftops of houses used for water supply. Why are these tanks always placed at a height? On the right of the page we have figure 6.4 depicting an overhead tank. On the page we have the picture of a young boy asking an important question. Do liquids also exert pressure? Let us find out by conducting the following activity. Activity 6.1. Let us try and find out. Take two transparent glass or plastic pipes of the same length, about 25 centimeters, but of different diameters, as depicted in figure 6.5. Take two good quality rubber balloons. Attach them to one end of each pipe. Clamp the pipes on a stand as depicted in figure 6.5. Now fill both the pipes with water up to the same level about halfway. Observe what happens to the balloons. Do both balloons bulge? Do they bulge to the same extent? On the right of the page we have figure 6.5 depicting equal heights of water columns producing same bulge in balloons. We can note a narrow pipe and a broad pipe setup on different stands. Water is filled in both the pipes and balloons are there. What can you infer from this activity? You must have observed that the two balloons bulge to the same extent. Why is it so? Notice that because of the different diameters, the weight of water in the two pipes is different. However, the bulge in both the balloons is the same. This means that the weight of water in the pipes could not be responsible for the extent of the bulge of the balloons. Could it be that the water column is exerting pressure? Yes, it is the pressure exerted by the water column which is responsible for the bulge. That is why equal water column heights produce equal bulges in the balloons despite their different diameters. Page 84. On the top of the page, there is a picture of a girl asking a question. What will happen to the bulge of the balloon if we increase the height of the water column? Pour some more water in any one of the pipes used in figure 6.5. Observe the bulge of the balloon. Repeat this process a few times, adding more water each time and noting the extent of bulge as given in figure 6.6. On the left of the page we have figure 6.6, which depicts higher heights of water column produce bigger bulge of the balloon. We have two different stands, with one in which the tube having the water has the balloon bulging out. In the other one, more water has been added and the balloon bulges out more. Do you note any relation between the amount of bulge of the rubber balloon and the height of the water column in the pipe? You must have observed that the bulge of the balloon increases as the height of the water column increases. Thus, as the height of the water column in the pipe increases, the pressure at the bottom of the pipe also increases, which causes the balloon to bulge more. So, we can say that the pressure exerted by a liquid in a vessel depends on the height of its column. This is the reason why overhead tanks are placed at a height so that the pressure in the taps is increased, resulting in a good stream of water from the taps. Suppose you are living on the second floor of a 3-storied building and an overhead water tank is placed on the top floor. Will you or your friend on the first floor receive a more powerful stream of tap water? Give reasons. A blank space has been given for your answer. Do liquids also exert pressure on the walls of the container? Let us find out by conducting the following activity. Activity 6.2. Let us find out. Take a used plastic bottle and remove its cap. Make 4 small holes near the bottom around the sides using a needle or a nail. Make sure that the holes are at the same height from the bottom as depicted in figure 6.7. If you find it difficult to make a hole, you can slightly heat the needle and poke it to make holes. Seal the holes with a tape and fill the bottle with water. Now remove the tape from all holes at the same time. What do you observe? On the left page, towards the bottom, we have figure 6.7, which depicts liquid exerts pressure on the wall of the container. There is a water bottle with holes and the water is oozing out of the holes. Page 85. You observe water flowing out through the holes on the sides of the bottle. What can you infer from this observation? It indicates that water also exerts pressure on the sides of a container. Therefore, we can conclude that liquids exert pressure not only at the bottom of the container, but also on its sides. In fact, liquids exert pressure in all directions. You must have seen water spurting out like a fountain from leaking joints or holes in water pipes. Can you explain why this happens? Is it due to the pressure exerted by water on the walls of the pipes? Ever heard of? Do you know that the base of a dam is much broader than the top? This is because a broad base not only supports the structure of the dam, but also withstands the horizontal water pressure near the bottom. Refer to figure 6.8. The water stored in the dam exerts pressure horizontally on the side walls of the dam and vertically on the floor due to the height of the water level. the pressure which acts horizontally is very large near its bottom. Thus, to withstand the pressure, the base of the dam is made broader. In the figure 6.8, we can note a dam. Refer to the picture given on the page, figure 6.8, which demonstrates this in the picture of a dam. On the right side, we have the picture of a young girl who is telling us about this interesting fact. Let us now try to understand if air also exerts pressure. 6.2. Pressure exerted by air. You already know that air is all around us. The envelope of air surrounding the earth is called atmosphere. The atmospheric air contains nitrogen, oxygen, argon, carbon dioxide, and other gases in small quantities. The atmosphere extends up to many kilometers above the surface of the earth. Let us find out if the atmosphere exerts pressure by performing the following activity. Activity 6.3. Let us explore. Take a paper plate, invert it, and attach a stick to it as depicted in figure 6.9a. Place it on a plane surface. On the bottom right of the page, we have figure 6.9a, which depicts inverted paper plate setup. We can note a stick and a paper plate on the table. Take two identical sheets of chart paper about 70 centimeters by 56 centimeters each. Fold one sheet twice and make a hole in the center of the folded chart paper sheet, big enough for the stick to come out. Page 86. Place the folded sheet on top of the inverted paper plate as given in figure 6.9b. Now try to lift the paper plate covered with a folded sheet using the stick. Observe how much effort is needed to lift it. On the left of the page, towards the top, we have figure 6.9b, which depicts inverted paper plate with two folds of chart paper. The girl in the picture is doing the activity explained. Now, place the second unfolded chart paper sheet in place of the folded sheet. Make a hole at the center of this chart paper for the stick to pass through. Cover the paper plate with the unfolded chart paper as depicted in figure 6.9c. Lift the paper plate again and feel the effort needed in doing so. On the left side of the page below figure 6.9b, we have figure 6.9c, which depicts inverted paper plate with unfolded chart paper. The girl in the picture is again doing the activity as explained. In which case is the lifting easier, with the folded or the unfolded chart paper covering the paper plate? You would have observed that more effort is needed to lift the paper plate when it is covered with the unfolded chart paper than with the folded chart paper. When we cover the paper plate with unfolded chart paper, the area of the covering sheet increases. The effort needed to lift the paper plate increases. Notice that the weight of the covering sheet has not changed. What can you infer from this? We can infer from these observations that air exerts force on the covering sheet, which makes it difficult to lift the paper plate. Moreover, this force increases with increase in the area of covering sheets. It means that the air is exerting a force on the paper plate which increases as the area of the sheet covering it increases. As force per unit area is pressure, we can conclude that air exerts pressure on the paper sheet. In fact, air exerts pressure on all objects. The pressure exerted by air around us is known as the atmospheric pressure. You must have experienced that when you blow air into a balloon, it gets inflated. Why? This is because the air being filled inside the balloon exerts pressure on the walls of the balloon. Refer to figure 6.10. On the left towards the bottom, figure 6.10 depicts a girl blowing a balloon. Can we say that air exerts pressure in all directions? Yes, that is why the balloon expands in all directions. What happens when an inflated balloon is kept without closing its mouth? The air escapes from the balloon. Why does the air escape from the balloon? Page 87. Have you ever wondered how large the atmospheric pressure is? Let us get an idea about its magnitude by performing the following activity. Activity 6.4. Let us perform. Take a good quality rubber sucker. Press it firmly against a smooth, flat surface as depicted in figure 6.11 on the right side of the page. Do you realize that it sticks to the surface? Now try to pull it off. Do you find it difficult to pull it off? When we press the sucker, most of the air between its cup and the surface on which it is placed is pushed out, and the air pressure inside it is reduced. The sucker sticks to the surface because the pressure of air surrounding the sucker is higher than the pressure exerted by the air inside the sucker. To pull the sucker off the surface, the applied force should be strong enough to overcome the pressure difference between outside the sucker and inside the sucker. Do you know how large the atmospheric pressure is? The force exerted by the atmospheric air column over an area of 15 centimeters by 15 centimeters is nearly equal to the force of gravity on an object of mass 225 kilograms, that is 2,250 newtons. The reason we are not crushed under this weight is that the pressure inside our bodies is also equal to the atmospheric pressure. This balances the pressure exerted from outside. The pressure inside our body is caused by the movement of fluids and gases in tissues and organs of the body. A step further. The SI unit of pressure is Newton per square meters, also known as Pascal, PA. However, the practical unit of air pressure is millibar, MB, which is equal to 100 pascals. Air pressure is also expressed in hectopascal, HPA, which is equal to 100 pascals. On the right of the page, we have the picture of a boy climbing a staircase. 6.3. Formation of wind. You must have noticed that on some days the wind blows strongly, whereas on other days it is calm. Sometimes wind becomes so strong that it causes damage to life and property. You must have seen that when an inflated balloon is kept without closing its mouth, the air from the balloon escapes. Recall that when there is a puncture in the bicycle tube, the air escapes and the tube collapses. In both of these cases, does air move from a high-pressure region to a low-pressure region? Page 88. On top of the page, we have a picture of a boy and a girl. Both of them are asking some interesting questions. The boy asks, "Does the difference in air pressure have anything to do with the formation of winds?" The girl further asks, "How do winds form?" Let us find out from the following activity. Activity 6.5. Let us observe. Take two similar balloons made of thin rubber and a drinking straw. Insert one end of the straw into one balloon and secure it with a rubber band or thread. Now inflate the second balloon and hold its mouth with your fingers so that air does not escape. Insert the free end of the straw into the neck of the inflated balloon and secure it with a rubber band or thread. Make sure that the air does not leak from the balloon as the straw is inserted in it. Now you have one end of the straw inside the inflated balloon and the other end inside the uninflated balloon as depicted in figure 6.12 on the left of the page. The picture clearly depicts air moves from a high-pressure region to a low-pressure region. Predict what would happen to the balloons. Observe what happens to both the balloons. Did it happen as predicted? Do you observe any change in the size of the balloons? Write down your observations. Some blank space has been provided. What can be the reason for the change in the sizes of the balloons? The air pressure in the inflated balloon is higher than that in the uninflated balloon. As a result, some air moves from the inflated balloon to the uninflated balloon, resulting in changes in the size of both the balloons. Do you notice that after some time, both the balloons attain almost the same size and the flow of air stops? Why does the airflow stop? The flow of air continues till the air pressure in the inflated balloon is higher than the air pressure in the uninflated balloon. The airflow stops when the pressure in both balloons becomes equal. At this stage, both balloons are almost of the same size. Thus, we can conclude that air moves from a region of high air pressure to a region of low air pressure. You can relate this conclusion to the directions of the sea breeze and land breeze, which you studied in Curiosity, Grade 7. As land gets heated faster than water during the day, the air above the land becomes warmer and lighter. Page 89. Hence it rises, creating an area of low pressure. The air from the high-pressure region of the sea blows to the low-pressure region, which develops on the land, resulting in a sea breeze. At night, the water is warmer than the land. Therefore, a low-pressure area develops above the sea. As a result, wind blows from the land to the sea, giving rise to land breeze. Thus, the phenomenon of land breeze and sea breeze is mainly due to the pressure differences over the land and the sea. If we could measure the speed of the escaping air in Activity 6.5, we would find that the speed of the air is higher if the pressure difference is higher. On the page we have a picture of a boy and a girl. The girl is telling the boy, "I have read that high-speed winds can blow off roofs." The boy asks, "I wonder how?" 6.4. High-speed winds result in lowering of air pressure. Activity 6.6. Let us observe. Take two balloons of the same size. Inflate both balloons and tie strings to them. Hang the two balloons from a stick, leaving a gap of 6 to 10 centimeters, as depicted in Figure 6.13 on the right of the page, where we can notice blowing between two balloons. Now, blow air into the narrow space between the balloons. What happens to the balloons? Note down your observations. Now blow harder and observe. When you blow between the two balloons, you observe that they move towards each other. This happens because when you blow air between the balloons, a low-pressure area is created between them. The higher air pressure surrounding the balloon pushes them towards each other. You must have observed that blowing harder increases the speed at which the balloons approach each other. What can you infer from this activity? We infer that high-speed winds are accompanied by a reduced air pressure. Page 90. When high-speed winds blow over houses, a low-pressure area is created over them, as high-speed winds are accompanied by a reduced pressure. Therefore, the air pressure above the roofs of the houses is lower than the pressure below them. If the pressure difference is large and the roofs are weak, they may be blown away, as depicted in Figure 6.14a on the left of the page. Here we can observe roof of a house blown away. That is why it is safer to keep doors and windows of the houses open during storms with high-speed winds. When the same wind moves over the roofs and through the houses, the pressure difference between inside of the houses and over the roofs is reduced to a large extent. This helps prevent the roofs from being blown off, as depicted in Figure 6.14b below Figure 6.14a on the left of the page. Here we can observe roof of a house is intact. You must have experienced that when high-speed winds blow during storms, they are sometimes accompanied by thunder and lightning. Let us learn more about them. 6.5. Storms, thunderstorms and lightning. We have the picture of a girl who is asking a question to a boy whose picture is on the right side. The girl asks, "Have you heard the sound of thunder and seen lightning during the rainy season?" The boy replies, "Yes, the sound of thunder is so frightening. Usually there is heavy rainfall too." When land gets heated, the warm and moist air, being lighter, rises, thereby creating a low-pressure area. Cooler air from the surrounding high-pressure areas flows to take its place. This air, in turn, gets heated and rises. This results in a continuous process of wind circulation. As the rising air expands, it cools and moisture in it condenses to form water droplets, creating clouds. The water droplets merge to form heavier drops which come down as rain, hail, or snow. The strong winds accompanied by rain is called a storm. In hot, humid and tropical regions like India, storms are more frequent. Under certain conditions, warm air rises to great heights that the low temperature there converts water droplets into ice particles. On the bottom left of the page, we have Figure 6.15, which depicts strong winds going up and down. We can understand the cool and warm air depicted in the picture through different colored arrows in blue and red. Strong winds blowing upwards and downwards, as given in Figure 6.15, facilitate rubbing between water droplets and ice particles. Page 91. You have learnt in the chapter Exploring Forces that when two objects are rubbed against each other, they get charged. In this case, strong winds blowing upwards and downwards and rubbing against each other cause static electric charges to develop within the clouds. The positively charged, lighter ice particles move upwards and occupy the upper part of the clouds. The negatively charged, heavier water droplets occupy the lower part of the clouds. Thus, a charge separation within the cloud takes place. Also, when the negatively charged lower part of the cloud moves closer to the ground, it causes the ground and nearby objects, such as trees or buildings, to become positively charged, as given in Figure 6.16. On the right of the page, Figure 6.16 depicts lightning. Normally, air acts as an electrical insulator and does not let opposite charges meet. But when the buildup of charges becomes very large, the insulating property of air breaks down. A sudden flow of charges takes place, producing a bright flash of light called lightning. Lightning can occur as opposite charges collide within a cloud, between clouds, or between clouds and the ground. Lightning rapidly heats up the air around it, causing the air to expand and produce a loud sound known as thunder. A storm accompanied by lightning and thunder is called a thunderstorm. A step further. Isolated and localized thunderstorms can sometimes occur in various regions of India. These thunderstorms are known by various names such as Kalboishakhi in West Bengal, Bihar and Jharkhand, and Bordoisila in Assam. They occur before the arrival of the monsoon, thereby helping kharif crops to grow. In Kerala, Karnataka and Tamil Nadu, They are known as mango showers, as they support the ripening of mangoes. Local thunderstorms in Karnataka help in the growth of coffee plants. On the right of the page, we have the picture of a young girl climbing a staircase. Lightning can be dangerous. It can ignite fires, damage buildings, and cause severe burns or death in humans and animals. We must take necessary precautions and protect ourselves from lightning. During lightning, stay away from tall objects, find a low-lying open area and crouch down, and minimize contact with the ground. Do not lie down flat. Avoid using an umbrella with a metallic rod. If you are in water, get out of it. If you are inside a bus or a car, you are comparatively safer. On the bottom right of the page, figure 6.17 depicts safe position during lightning. The person has put himself in the best possible position to avoid getting struck by lightning. Page 92. Ever heard of? A lightning conductor is a metallic rod installed along the walls of buildings during their construction. One end of the rod is pointed. This end is kept higher than the highest point of the building. Refer to figure 6.18. The other end of the rod is buried deep in the ground. The rod provides easy path for the transfer of electric charges into the ground. Figure 6.18 depicts a lightning conductor, which has been installed on the top of the building, with the other end buried deep in the ground. 6.6. Cyclone. Cyclones are large storms that form over warm ocean waters. As the ocean water gets heated, the warm and moist air above it rises. As the moist air rises, the water vapor condenses to form raindrops. We know that during evaporation, water takes up heat to change into vapor. When this water vapor condenses into raindrops, heat is released back into the atmosphere. This causes further warming of the ascending air, leading it to rise even further, creating an even lower pressure. Air from the surrounding regions rushes in, and it also starts rising. Earth's rotation causes the moving air to spin. Refer to figure 6.19 on the left, which depicts winds blowing from high-pressure areas to low-pressure areas. We can also observe the different pressure zones created in the process, varying from high pressure all the way to low pressure. This cycle is repeated, resulting in the creation of a very low-pressure area with high-speed winds revolving around it. This spinning system of clouds, winds, and rain is called a cyclone. In a cyclone, the region of lowest pressure is at the center, known as the eye of the cyclone. At the eye of the cyclone, the wind is calm, but the surrounding region experiences strong winds and heavy rainfall. As a cyclone moves from the ocean towards the land, it generates higher wind speeds compared to the wind speeds produced by regular thunderstorms. Once the cyclone reaches land, the source of moist air is cut off and it gradually loses its strength. On the bottom left of the page, in figure 6.20, we can observe a cyclone. We can also observe the eye of the cyclone, which is calm area. Page 93. Even as a cyclone loses its strength while traveling over land, it leaves behind a trail of destruction that can take months or even years to repair. Cyclones can be extremely destructive. For example, the Amphan cyclone in 2020 had peak wind speeds of 270 kilometers per hour. Strong winds during a cyclone push ocean water towards the shore, creating a wall of water that can be as high as 3 to 12 meters. This surge of water can flood coastal areas and even areas far from the sea. The heavy rainfall which accompanies a cyclone may cause rivers to overflow and can also trigger landslides. Seawater that rushes inland can contaminate drinking water sources and damage farmland. The salt in seawater can make soil less fertile, affecting crops. Roads may get blocked due to fallen trees and debris, making it difficult for help to reach the affected areas. Power outages can last for days, disrupting emergency services and daily life. How can we protect ourselves during cyclones? It is important to stay updated on weather reports and periodic alerts and warnings issued by the India Meteorological Department, IMD. Thanks to the weather monitoring satellites, today we can track cyclones and predict their path, helping us reduce their impact on life and property. Several national and international organizations work together to monitor cyclone-related disasters. If you live in a cyclone-prone area, keep an emergency kit ready with essential items. During a cyclone, quickly move to a nearby designated cyclone shelter. Let us wrap up. Warm air rises, creating a low-pressure area. Cool air rushes to occupy the low-pressure area. Warm air rises, cools, and the water vapor condenses to form clouds. Bigger water drops in the clouds fall to the ground as rain, hail, or snow. Positive and negative charges are created in the clouds by strong winds blowing upwards and downwards. When positive and negative charges meet, they cause lightning. Lightning may occur within a cloud, between clouds, or between a cloud and the ground. Under certain weather conditions, storms may develop into cyclones. Page 94. Snapshots. On the top left of the page, in the left corner, we have the picture of a young boy with a carry bag and a phone which is being used to click some snapshots. Pressure is defined as force per unit area. The SI unit of pressure is Newton per square meters, N/m square, and is also called Pascal, denoted by capital PA. Liquids and gases exert pressure on the walls of a container. The pressure exerted by the air around us is known as atmospheric pressure. Differences in air pressure cause winds to blow. Warm air rises, creating a low-pressure area. Cooler air from surrounding higher pressure regions moves in to take its place. Important requirements for the formation of thunderstorms are moisture and strong winds. Strong winds moving upwards and downwards facilitate rubbing of ice particles with water droplets, causing electric charges to develop in clouds. Collision of electric charges within clouds or between a cloud and the ground causes lightning. Lightning strikes can cause destruction to life and property. Lightning conductors protect buildings from the effects of lightning. The Indian Meteorological Department, IMD, constantly monitors cyclones and thunderstorms in India. Keep the curiosity alive. 1. Choose the correct statement. 1. Observe figure 6.21 carefully. Vessel R is filled with water. When pouring of water is stopped, the level of water will be dash. A. The highest in vessel P. B. The highest in vessel Q. C. The highest in vessel R. D. Equal in all three vessels. On the left of the page, we have figure 6.21 depicting three vessels P, Q and R and the activity of pouring being done. 2. A rubber sucker M is pressed on a flat smooth surface and an identical sucker N is pressed on a rough surface. A. Both M and N will stick to their surfaces. B. Both M and N will not stick to their surfaces. C. M will stick but N will not stick. D. M will not stick but N will stick. Page 95. 3. A water tank is placed on the roof of a building at a height h. To get water with more pressure on the ground floor, one has to A. Increase the height h at which the tank is placed. B. Decrease the height h at which the tank is placed. C. Replace the tank with another tank of the same height that can hold more water. D. Replace the tank with another tank of the same height that can hold less water. 4. Two vessels A and B contain water up to the same level as depicted in figure 6.22 on the right of the page. PA and PB is the pressure at the bottom of the vessels. FA and FB is the force exerted by the water at the bottom of the vessels A and B. A. PA is equal to PB, FA is equal to FB. B. PA is equal to PB, FA is less than FB. C. PA is less than PB, FA is equal to FB. D. PA is greater than PB, FA is greater than FB. 2. State whether the following statements are true or false. 1. Air flows from a region of higher pressure to a region of lower pressure. Dash. 2. Liquids exert pressure only at the bottom of a container. Dash. 3. Weather is stormy at the eye of a cyclone. Dash. 4. During a thunderstorm, it is safer to be in a car. Dash. 3. Figure 6.23a depicts a boy lying horizontally and figure 6.23b depicts the boy standing vertically on a loose sand bed. In which case does the boy sink more in sand? Give reasons. On the right of the page we have figure 6.23a and below it figure 6.23b. In the first picture the boy is lying horizontally and in the second one he is standing vertically on a loose sand bed. 4. An elephant stands on 4 feet. If the area covered by 1 foot is 0.25 square meter, calculate the pressure exerted by the elephant on the ground if its weight is 20,000 newtons. Prepare some questions based on your learnings so far. Some blank space has been provided for you. On the bottom right of the page we have a picture of 5 kids who are already asking some interesting questions like why, when, how long, where, why not? Page 96. 5. There are 2 boats, A and B. Boat A has a base area of 7 square meters and 5 persons are seated in it. Boat B has a base area of 3.5 square meters and 3 persons are seating in it. If each person has a weight of 700 newtons, find out which boat will experience more pressure on its base and by how much. 6. Would lightning occur if air and clouds were good conductors of electricity? Give reasons for your answer. 7. What will happen to the 2 identical balloons A and B as depicted in figure 6.24 when water is filled into the bottle up to a certain height? Will both the balloons bulge? If yes, will they bulge equally? Explain your answer. On the left of the page we have figure 6.24 where we can note 2 identical balloons A and B connected to the bottle and water is being poured into the bottle. 8. Explain how a storm becomes a cyclone. 9. Figure 6.25 depicts trees along the sea coast in a summer afternoon. Identify which side is land, A or B. Explain your answer. We have figure 6.25, which depicts a coastal area in a summer afternoon. On the left we have the side A and on the right we have the side B. Trees are swaying in the wind due to the pressure. 10. Describe an activity to show that air flows from a region of high pressure to a region of low pressure. 11. What is a thunderstorm? Explain the process of its formation. 12. Explain the process that causes lightning. 13. Explain why holes are made in banners and hoardings. Reflect on the questions framed by your friends and try to answer. Some blank space has been provided for you. We already have 5 kids, very inquisitive and ready with their thoughts on the bottom left of the page. They are saying, I think, but we thought, maybe, shouldn't it be? Page 97. Discover, design and debate. Hold a strip of paper 18 centimeters long and 2 centimeters wide between your thumb and forefinger so that it hangs freely. Predict what you will observe if you blow over the paper. Perform the activity now. Note down your observations and interpret your results. List 3 major cyclones which have occurred in India in the last 20 years. List 2 major destructions caused by each of the cyclones. What measures were taken by the local government and communities to reduce the loss of life and destruction of property? Mention 2 suggestions you would like to propose to the local government. Collect data on the strength of thunderstorms for various regions of India. Compare your findings and identify which regions are more prone to thunderstorms. Can you give reasons for your findings? On the right of the page, we have a picture which clearly depicts that science, society, and interdisciplinary projects go hand in hand, just like good friends or family. This chapter ends here.
Curiosity. You were just listening to this audiobook, Textbook of Science for Grade 8. Narration, Gaurav Marwa. Sound recordist, Mohammad Faizan Khan. Assistance in production, Soumya Malik. Directed and produced by Vimlesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.